Welcome to Mission 2, Lesson 10 of Zearn. Our goal today is to be able to multiply by tenths. We are going to use a combination of estimating, multiplying by area models, and multiplying using the standard algorithm to complete our goal. We will know we've been successful if we are able to complete Mission 2 of Lesson 10 on Zearn.org. Let's begin with the problem 57 times 2 6/10. The first thing we want to do is estimate and round to be able to do that. 57 is closest to 60, and 2 6/10 is close to 3. So now we would be able to estimate. 60 times 3 is 180. Now let's look at our original problem here and see if we can determine if the answer will be greater than or less than 180. Well, I know that 57 is less than 60, and I know that 2 6/10 is less than 3. So my answer for the actual problem is going to be less than my estimate. Now let's solve using the area model. For the sake of solving this problem, we're going to take the decimal out for right now, and then we're going to put it back in at the end. Pause the recording, and when you've come up with your partial products that you've added together, then come back and check your answers. Great. As you can see here, I have 3 zeros in my partial product when there are only 2 in the problem. The 2 in the problem go at the end, but then 2 times 5 is 10, and so 10 goes in front of those 2 zeros. Same thing here. I have 1 zero in my problem, which is at the end of my answer. But then 6 times 5 is 30, which goes in front of that 0. Now let's solve using the standard algorithm. Once you have done so, go ahead and come back to the recording. As you can see, both strategies for solving give us the same partial products. And now we need to add them together. I used this before, so it doesn't belong there anymore. So now I'm at 1,482, but I have to put my decimal back in. And there's a couple of different ways that I can find out which way to do this. Let's take a look at these 3 options. I want to also compare it with the estimate that I came up with in the beginning. I said that the answer to our original problem should be around 180. I also determined that it should be less than that 180. So if it should be around 180 but less than, let's look at where the decimal points are in these 3 choices. Here, that is less than 180, but it is not around or close to. If I look at 14 and 8200ths, that is not close to 180 either. If I look to 148 and 2/10, that is close to 180, and it is also less than. So this would be where I put my decimal. Another way that I can look at it is I can count the number of places that are after all decimals in the problem, and that's how many I want to go in with my decimal when I put it into my answer. The only decimal I have in the problem is right here, and there's 1 place value after it. So that means I want to come in 1 place value with my decimal. And as you can see, those are both the same. Let's try another problem. Our problem is 31 4/10 multiplied by 62. The first thing I want to do is round so that I can get an estimate of what my answer should be. Go ahead and round these two numbers and estimate. 31 4/10 is closest to 30, and 62 is close to 60. So my rounding is 30 times 60. 3 times 6 is 18. And there are 2 zeros in my problem, and I added 2 zeros onto the end. So I know my answer should be close to 1,800. But should it be greater than or less than 1,800? Well, 31 4/10 is greater than 30, and 62 is greater than 60. So I would expect for my answer to be greater than 1,800. Now create an area model and solve using a standard algorithm. Then come back and we'll check your answers. Remember, right now we're going to take the decimal out and we'll put it back in at the end. As you can see, both ways we came up with the same partial product again. And when added together, we get 19,468. But we still need to add our decimal back in. So we know that our answer should be around 1,800 and that it's going to be greater than. What would make sense for where the decimal should be? What would be reasonable? Yes, 1,946 is greater than and still close to 1,800. So it would be reasonable that our decimal would be right there. 1,946 and 8/10. Hope this helps.